Yes. Okay. This is good. Okay, here we go. 60 degrees, 8 meters per second. So we're going to kick a ball 60 degrees, 8 meters per second, and it's going to go, and it's going to come down over here at some speed with some angle, which we're going to try and figure out. And the things that I want to know are, what is the time of flight? What's the range? What's the maximum height? It is a lot of work, actually. And then what's the final speed over there? V final. And what's the ending theta? Oops. Nice. How much time do we have? That's a good question. Okay, so we've got these issues here where, like, how do you go about even starting something like this?
You have to make a triangle out of the first.
You do have to make a triangle out of the first thing. So let's make a triangle out of this. Vx and how about if we do green? We'll go Vy.
Okay.
And this was 60 degrees. Let's put it back. Okay, so first thing, you have to get rid of your original speed and turn it into a triangle.
Yeah.
That is always the case. So what is Vx? What's Vy? Aha, so Vx equals
Sine.
V cosine
Oh, it's cosine.
of 60 degrees, and Vy is V sine of 60 degrees.
I love trig.
I know! So what do they turn out to be?
Something.
Something is what?
Alpha is the tangent of. Wait.
30, 60, 90,
You have
One of them is 4. Very good.
Yeah.
It's a special triangle.
Short one's 4.
The short one is 4. Which one's the short one?
Well, actually, yeah. Wait a minute. Is this like the perfect one? Where there are always good numbers?
No, the Vy does not turn out to be a nice angle or a nice number.
It's like root k.
Yeah, it's like, is it root 3 over 2?
No, I think it's just root 3.
Root 3? Yeah.
So like
Just
1
do
point.
8
What would be like
8 cosine of 60.
8 cosine of 60, right. So if we're solving this at home, we would do 8 cosine of 60, and then we would do 8 sine of 60. And you would stick that in your calculator, and you would get 6.9 meters per second. Like so.
Wait, so how, wait a minute. Wait, hold on, whoa.
I love it when Sterman draws the triangles.
Yeah, I was like, whoa, what's going on here? Because, there is a longer.
Well, no, the reason I said, yeah, because the 60-degree angle is less than 45.
Yes. I did not draw it to scale. Right. This angle should really be like up here, which
Yes.
would mean like this side's much longer and this side's much shorter.
It was just fast draw.
Yes.
And then
Quick
we
draw.
can probably do.
Okay, my brain understands.
And then we should do.
Make a chart of Y.
Ooh, yes, we should. Very good. Okay, so make a chart of Y. What do we know?
Initial x velocity and initial y velocity.
So does the x velocity stay the same?
Yes.
Pretty sure these are literally just going to be the
And
same.
they're 4. And what's our acceleration?
0.
Nothing. Right? Because there's no forces unless air resistance,
So we don't.
but never take air resistance into account unless the problem says you have to do it. Okay, so VI, VF, acceleration is 9.9, 9.8 negative?
Yes.
Sure. This is 6.9.
Are we doing like changing? Yeah, that's 0.
Okay, and then we need time down here.
Change in air.
Change in y is 0. Right?
Ooh.
No, because it goes in the air.
Well,
Ooh.
it lands
Oh,
on
wait,
the
no, but
ground.
it does land back on the ground and then go straight, so then it ends up not doing anything.
That's how we do
0.
That is so
Well, that-
gross.
Yeah.
It's true though,
That is so gross.
right? We go up and then we come down. No change in height. No change in height. It's weird. It takes a while to get used to. Like what? What is this crap? Like
Unless it's
put it in
asking
here.
like the height. Okay.
Ooh, right. So
What
it-
it is at that
I
height.
did want to know what is our maximum height.
Time divided by 2.
Ooh, so we're going to be interested in time, and then we're going to take our time halfway, because why are we going to do the halfway time?
Because that's the apex.
Because that's the apex. That's where we get our maximum height. So we're going to be interested in these two things. So now we got to figure out, well, how do I get time so I can divide it in half?
Kinematic formulas.
Kinematics formulas.
I don't know where my formula sheet is.
Oh no!
Probably
Loss of formula sheet.
You lose your formula.
I think if
How
I
do you lose your
go.
formula sheet?
Okay, first of all, I have so many stuff in here.
Now you'll get the green one of shame.
Green
This is last year, so it's got other stuff on there you don't need.
Thank you.
It's okay. All right, how do I solve for something?
Well, you can do the change in y equals initial velocity times time plus half of at squared.
Okay, so change in y equals v0t plus 1/2 gt squared.
GT.
Read that.
And we got this weird v hanging out of there. That's
And
messing
then
me up.
you just plug in the numbers and pray.
Okay, so by changing y is
0.
0 equals 6.9 t.
Plus 1/2 negative 9.8.
See, but the
Four
problem is,
point-
the
4
problem-
point, yeah, 4.9.
the problem is that this one gets ugly.
How do you solve that?
Oh, you gotta.
Quadratic formula. Okay, so now two things. On WebAssign, if you get to this point, you should use your calculator. Use it. Or mathways.com.
Yes.
That's what.
Mathways will solve it for you. Why am I telling you to cheat?
Because why would you put yourself through the quadratic formula 70
Yes.
million times?
And they never ask this on the test. Never, never, never. I've never seen a question where they're asking you to solve the quadratic equation. They could conceptually ask you questions about like why would there be two roots? Like, why are you getting the quadratic formula? There's going to be two answers. Why are there two answers? Or how do you know which one to pick?
Because it's a parabola and
because
you
it's a-
start and end at the same.
There you go. So that's legal, but doing the math, I've never seen it.
How would you plug this into the calculator? You just plug it into the graph and then like.
Okay. What do you have? An 84?
Most of us have 84.
Usually how I did
plus.
this on top was I.
You
just put
should
it-
have a quadratic formula solver built
I
in.
think
I can
it's,
probably look it up.
it is,
It's a weird thing. You have to like go in like second. Your
Numeric solver.
no, not numeric.
I can probably look on.
You
YouTube.
probably could just plug it into graph,
That's what I did. That's what I did.
Yeah, you could do that.
And I look for like
and it gives you the roots. It gives you like your roots, your max height,
Mm-hmm.
your y intercept. Yeah.
Okay.
Gives you all
So,
the funny stats that you need.
yes, it does. Okay, so when I do it, because since I have an 86, mine is built right in, you see. I can easily access it. When I solve this thing for t, t gives me the very surprising root of 0. Because that's where it started at 0. Yeah, it started
And
at
then your
0.
other one is
1.4 seconds. So
Okay.
which is the correct answer? 1.4 seconds, right? Because we started here, so that's why time was 0. And we're going to end at 1.4 seconds. So now we know our time is
That's
1.4
amazing.
seconds.
And then we can find the change in x.
Yes. Now, what's a half time?
Half time.
0.7 seconds. It's literally half of the time. Now, I'll show you a way to do it without quadratic formula.
There is another formula you could have used to find a different thing.
We are going to make a symmetry argument. Symmetry argument. So if I start out going 6.9, what's my speed when I come back down?
Not 6.9.
So what is it?
9.8.
Nope.
Negative
6.9, negative 6.9.
Wait, what? Why is your initial negative? You're going up.
I'm going up. That's 6.9. Oh, I mixed them up. Sorry.
I was like,
There we go. Good call. I was wondering why I was about to get a negative time. So in the beginning, I'm heading up at 6.9, and I'm arguing that because of symmetry, this is a perfect parabola, that when I come back down, my speed will be negative 6.9.
In the y direction.
In the y direction only, correct. So now I can solve this. 6.9, 6.9 is
0.
negative 14.
Oh wait, yeah, because
9.8 t is going to be 1.4.
Oh wow. We really just not caring about decimals.
Yeah. Yeah, I know. I was super lazy. Sometimes I just said like, oh, this is 10, but it turns out to be like 1.41 or something seconds. So.
I plugged in like a sign that was off by like 4 degrees into my calculator, and WebAssign was still like, okay.
Oh, it makes a huge yeah. And WebAssign, do not cheat. Like, take a whole bunch of decimal places.
No, like
'cause it's
WebAssign,
gonna-
like my answer was probably off by hundreds, and it was like, okay, whatever, it's fine.
All right.
There really is-
So I want to know the range. How far did it go in the 1.4 seconds?
V equals x over t.
So V equals x over t, and our V is 4. 4 equals x over 1.4.
So it's like
4 times 1.4
4 times 1.4 is
4 point something.
5.6 something. Turns out I rounded it to 5.7.
okay.
But I think it turns out to be.
V, and then we know V final is negative.
Ooh, we do know V final is negative 6.9.
And that's it. That's our job. We did the
Now to
table.
find the
Table
theta.
complete.
No, what's our maximum height?
Oh, just plug in 0.7 for one of the dynamic kinematic formulas.
Which one of the kinematics
I don't
formulas?
The easier one.
The easier one, which is
Vy, or what's it called? The height equals.
Change in x equals initial, or final velocity plus initial velocity over 2 plus t. Let's see.
Times V.
Plus t. Here. Unless it's not.
Wait, what?
Look at the, where's the equation sheet?
I don't have
oh,
that.
this is a fascinating one to pick.
I don't have
I'm gonna be honest, this is one I
It's not
like
an
looked up, I just wrote
No,
down 4
this is
that-
good. No, you can definitely pick this one. But now we've got a discussion here. What's my beginning speed?
6.9.
What's my ending speed?
Ah!
Oh no.
Negative 6.9.
So what's my height?
0.
Oh, wait a minute. Where are we talking about? If where my height is 0?
Halfway.
Oh, so it's 0, wait, the final velocity is 0, wait.
Yeah, why is my
Yeah.
final
Oh,
velocity?
because you hit the apex, so it's gonna start going down, but you hit the perfect
Exactly.
point.
Don't forget, like this is what makes these kinds of questions really hard, is you have to remember, like, wait a minute, where am I when I'm solving this problem? Like, I just put in 6.9 and negative 6.9. I am here. That's why I got a 0. My height is 0. That makes total sense. But if I want to solve it up here,
Oh.
what's my final speed?
0.
0.
Because the velocity at the top is 0, right?
Because velocity at the top is 0. Tom.
Is
it possible to draw a parabola graph that includes speed on the same graph? Or it has to be like 3 years or something?
That's a great question.
Also, when you're doing height,
probably you would need to take the derivative of this function though. So you need some calculus, and you need an 89, I think, in order to be able to do it. So it can be done, but I don't think it's worth the time.
an 89.
Yeah.
Like a TI 89?
Yeah, because then you can just say, give me the derivative of this function, boom, and it
Yeah,
would
Those are really powerful.
it would just
How
like
expensive
They're
pop out.
also impossible.
Like
to
hundreds
use.
of dollars?
No,
Like, they're all of the
120.
Texas Instruments calculators
Yeah.
are the same price.
They're all like,
Well, why not just get the
They're
better?
between like 100 and 180 depending
Okay.
on if you
So,
buy it.
we could solve it this way. That's a good way to do it. I actually never think of this formula. I think of this formula. Change in y equals v0 t plus 1/2
Yeah, that's what I'm
Yeah,
doing.
that's
Squared.
good classic.
So this one has pitfalls too. Delta y equals, my beginning speed 6.9. What's my time? 1.4 seconds.
Wait, no, wait a second.
If you plug in 1.4 seconds, what are you going to get as your
You're gonna get
answer?
0.
You're going to get 0. Because 1.4 seconds is here.
Oh.
Where are we?
Oh.
We're at
We're back to high
0.7
school.
seconds. We're at 0.7 seconds plus 1/2. Oh, so this will be
4.8.
4.9 times 0.7 seconds.
You almost did it.
I did.
D.7.
Now the other classic Sturman move is to forget that negative sign.
Squaring 0.7 twice.
Don't forget that negative
Why are you
sign.
squaring 0.7 twice?
Oh. Right
Never
there.
happened.
Yeah, then what do you get?
Give the answer.
You do get the
That's
answer.
so true.
And it turns out to be
Something.
2.4 meters. 2.4 meters. Okay, wait a minute. Symmetry argument. What's my speed here? Ooh, in what direction?
Down.
Downward. Negative 6.9. That's not what I asked though. I want to know what my whole speed is.
It says 4 point whatever, 4.
Aha, yes it does. This side stays 4.
That's opposite over adjacent, which is tangent, and then just plug it in.
Hmm.
Opposite is negative 6.9 divided by 4. Negative 59. Negative 16.
That's weird
Oh, wow. Coincidence.
because symmetry says,
What a coincidence.
what a coincidence. It's going to be exactly the same. This is going to be 60 degrees. That's going to be 8 meters per second. Right? It is completely. No, because it's at an angle, and so I would avoid talking about the velocity, because you're right, it's going downward, but like I don't know how to describe that. I would say it's 8 meters per second at 60 degrees south of east, like so. Wow, we're gonna run out of time. We did run out of time. We'll pick up and solve some more of these on Friday.
It's on,
Is that marking period 1
I'm
or
moving
2?
Yes.
Becky to
Oh
the
yeah,
main
the
office,
quiz
please.
is on last
Becky
week's
to
homework.
the main office, please.
Quiz.